Hello everyone, myself Jyoti Laddi. I am studying in BSc 4 SEM. My combination PCM, my seminar topic, third law of thermodynamics. First, let us see the introduction of the third law of thermodynamics. Nernst work on the heat theorem and electrochemistry has very great impact on the physical science. He was one of the great pioneers of the physical chemistry and he said that he had it had taken three peoples to formulate the first laws of thermodynamics. Two for second law of thermodynamics has been obligated to the third law of all by himself, and that it is followed by the extrapolation that three could never be a fourth law. The Nobel Prize, the 1920 Chemistry Nobel Prize for this works, whether the next, the German chemistry was awarded to the 1920 Chemistry Nobel Prize. This work is thermochemistry. The first and second law of thermodynamics have led to new concepts of energy, content, and entropy. The third law, however, that does not lend to any new concept. It only places a limitation of the value of entropy of crystalline solid. Some scientists hesitate to call it a law at all. Next, the determination of absolute entropy of solid, liquid, and gaseous. Solid, liquid, and gaseous. To the equation 1, we have ds equal to dq by t. In the if the change takes place in a constant pressure, this is equation 2. Constant ds by d dot t, dou s by dou p, dou t equal to dou q by dou t, p 1 into 1 by t. This is equation 2. And definition by cp dq by dou q by dou t pressure, and equation 2 become this one, that the constant pressure ds cp by t dt. For the perfectly crystalline substance, the absolute entropy is equal to 0, t equal to 0, therefore we may be right. And next, where is the empirical constant? Physical science is known as the d by t cube law of, according to the equation 6. This is equations 8. 8 is r equal to 1 by 3 a t cube plus integration t not t cp dt by t. This is equation 8. The absolute entropy of a substance, whether solid and liquid at gas at a temperature T, can be determined as illustrated below. For the first one, solid. For determination, the entropy of the first of a solid should be known the heat of capacity of the solid. He is determined from d by t cube law, which given by ninth equation, where CPS equal to AT cube is the equation 9. CPS is the heat capacity of a solid. The entropy will be become this one, SR. And next, integration from s to 0, s equal to 0, ds equal to integration t to 0, t equal to 0 to t equal to t c naught by t dt. Equation 4 and 5, the mathematical formula, where S3 is the absolute entropy and crystalline solid under the examination at the temperature T. And equation 4, we write the equation 4. Equation 6 is t, where 0 less than t less than 15k, the force integral evaluated with the help of Debye theory of the heat capacity of crystalline substance, according to the which at very low temperature. Equation 7, SCP equal to CV equal to AT cube. And next, topic is a main important topic, third law of thermodynamics, according to the equation 6. According to the equation 6, delta Cp tends to approach the 0 at 0K. This means the absolute zero. The Nernst heat theorem can be written as a limit T is to 0, Cp equal to 0. This equation 7. According to equation 5, delta has become a 0, absolute 0. The entropy change of a process involving solid become a 0 at OK, 0K, absolute 0. In other words, the absolute entropies of products and reactants in the solid state are identical. Planck therefore suggestion the entropy of all pure solids approaches 0 at 0K. Equation 8, S equal to 0, Cp equal to 0. Equation 7 and 8. And this lends to formulate the third law of thermodynamics statement. At the absolute zero of temperature, the entropy of every substance may be become a zero. On it does become a zero in the case of perfectly crystalline solid. This is important. Next, for liquid, these equations including mathematical formula. T mean is a minimum temperature to which the value of a heat capacity. For the next one, for liquid is the entropy of liquid temperature T is determined as follows. The second is heat, the temperature 0 Kelvin absolute 0 to its melting point Tm. The solid is transformed to liquid at its melting point Tm. Then the liquid is heated to temperature T. Thus, by the addition these three processes, we get the St. This St. St equal to. This is the equation for liquid. For liquid, for next one, gaseous. Similarly, for gas, the entropy of the liquid similar to gas, liquid tarana, similar gaseous to entropy of given by this equation St. Graphical representation: solid, liquid and gaseous entropies are graphical representation of the absolute entropy of solid, liquid and gaseous. Importance of the third law of thermodynamics is given by it helps in calculating the thermodynamic properties. It explains the third behavior of solid at a very low temperature. It helps is analyzing chemical and phase equilibrium. And next part of numerical problems. EMF is thermocouples with the test function. This is example 1. That the solution uh, formula use the formula. Hence the when gas thermometer reads 50 degrees Celsius corresponding to 8.75 MV, the thermometer will be read 100 by 15 into 8.75 equal to 58.33 degrees Celsius. This is the answer. And second problems also answer given this in read the all question and answer these. 130 Kelvin farad answer the mercury water. This is experimental and measured by the multiplied manometer. The tank is located on the mountain 40,000 altitude where the entropy pressure 85.6 kg per determine the pressure in the tank. This is P1. This formula, this is calculate the 130 Kelvin farad answer this one. And reference physical reference principle of a physical chemistry, 4th edition by the Samuel H. Morrell, Carey F. Proton. and B.R. Puri, R. Sharma, Mandan, SP. Thank you.